thank you very much. And it's my great pleasure to present my work on your DeFi seminar. I'm going to talk about today. I'm going to talk about monetary policy uncertainty and the cryptocurrency volatility. We will. This is what I'm going to talk about the alternate. I will going to talk about the motivation. As we all know, cryptocurrency has gained a great success. Bitcoin is described as a digital gold, and we have noticed that the total capital cryptocurrency has reached $1 trillion. And the success of cryptocurrency has attracted a great attention on governments, and the media and economists. And cryptocurrency can act as a safe haven for a variety of assets, offer diversification, hedging benefits. However, cryptocurrency seems to be more volatile than traditional assets, and this is the comparison. The blue line is the volatility of Bitcoin, and the red line is the volatility of U.S. stock market. You can see that the volatility of Bitcoin is 10 times volatile than U.S. stock market. And intensive literature has examined what determines the volatility of cryptocurrency. And to the best of our knowledge, few studies have examined the impact of monetary policy uncertainty on cryptocurrency volatility. However, monetary policy should have a greater impact on cryptocurrency prices. In practice, like model wrote that chancellor on brink of a chancellor on brink of second bailout for banks in the Genesis block. It gives a hint that cryptocurrency is closely related to monetary policy. And in theory, the evolution of cryptocurrency prices is correlated to that of the fiat monetary policy. In fact, currency-based digital assets experienced idiosyncratic spillover after U.S. monetary policy announcements. So our paper will examine the impact of monetary policy uncertainty on cryptocurrency volatility. First, we will describe the data. We will adopt. There are two approaches to measure monetary policy uncertainty. The first is the market-based monetary policy uncertainty. However, a market-based MPU contains a component related to time varying risk aversion that could also impact the volatility of assets. So we would like to adopt a news-based monetary policy. In the paper, we will adopt the index constructed by Hosted. It can better capture uncertainty in periods of unconventional monetary policy when the federal funds rate is near or at the zero low bound. And this is the figure of monetary policy. We can see that when the COVID breaks, monetary policy uncertainty declines, and before it it is very high, and recently we can see that monetary policy uncertainty is high. Oh, we in current study we will study the U.S. monetary policy uncertainty on cryptocurrency volatility, and in fact we also examine the other NPO or other countries. However, the conclusion is a little bit confusing. So we're still working on it. We're still working on it. Working on it.
Sorry, can I ask a clarifying question?
Yeah.
So when the COVID hits, why would we expect the monetary policy to be less uncertain, but not the other way around? Could you give us more intuition on that?
Yeah, when in fact when COVID comes, you know, the economy is give a sudden freezing. Yeah, and for monetary authorities, it should give a clear policy guide to more clear policy to promote the economy. Can explain the fall down or monetary policy uncertainty during COVID period?
I see. Okay, thank you.
Oh, thank you. And for cryptocurrency, we'll select Bitcoin, Ethereum, Dogecoin, Ripple, and Litecoin, Stellar, Monero. This cryptocurrency has a relative non-sample, and the sample starts when trading volume is available and ends in April 2033. And we know volatility is a hidden state variable. We can see it, and so we measure with realized volatility with some the square the returns of that month and take log value that. Take a log value will give a more behaved volatility. It is more close to normal distribution, and we know we will use OLS to estimate the equation. So this will give us a more accurate estimate. And besides the individual cryptocurrencies, we also construct an equal-weighted market return or cryptocurrency market. We struck equal-weighted, not value-weighted, because Bitcoin and Ethereum is overwhelming dominance in cryptocurrency market. So we just construct equal-weighted market returns. And this is a picture of three typical cryptocurrency and the market return. We can see the volatility of Bitcoin and Ethereum is very quite different. And this is the summary statistics. We can see that it makes me a little surprising that is the volatility of cryptocurrency is a lot persistent. In fact, traditional asset, the volatility of traditional asset is very persistent, as we all know. But the first order article relationship for cryptocurrency is less than 1.5, and so this is however, when the sample is ended in 2019, the first order relationship is about 1.9. It indicates that volatility of the cryptocurrency is also still persistent during the first sample period. So what happened? What happened to volatility of cryptocurrency market? I don't know. It seems includes the last 2 years sample. It decrease persistency of volatility of cryptocurrency apparently. And we now we give some empirical analysis. First, we will give in-sample analysis. We will double pair the univariate forecasting regression model. We include AR terms and include monetary policy, and the lag is selected according to BRC criteria. And the in-sample analysis indicates that monetary policy is a stronger predictor of cryptocurrency volatility, and the slope is selective and significant at the conventional level. It implies that a high monetary policy and indicates low cryptocurrency volatility.
Sorry, so here when we look at H equals to 1, 2, 3, 4, 6, should we think about those as quarters or months, or like what is the lag here?
The 1 month, 1, 2, 3 months, and 6 months. Yeah.
Got it. Thank you.
In fact, we want to examine the for cryptocurrency market, the time is still short. We would like to examine the in week horizon, but the market policy uncertainty, the data is not available. So we just can examine it in month frequency. And we would like to control all the economic variables. We include Standard Poor's 500 realized volatility, global realized economic activity, and trade weighted USD dollars index return, and the implied volatility of gold. These variables are shown to be the most significant predictors in the literature, and we can see that first that their variables is things they are not stronger predictors anymore. And however, we first report the univariate models. We can see these control variables are all not significant anymore. And so we include them. They don't change the significance of monetary policy uncertainty. And we have examined the in-sample analysis, but however, in-sample analysis can estimate the estimate more accurately. But however, it may also suffer from overfitting problem. And besides, when investor allocate their assets, they can only use the current the current information, and cannot use the full sample information. So we perform out sample analysis. We will adopt a recursive estimation to examine our out sample analysis. The coefficients are estimated with data prior to period t, and we will evaluate the outer sample predictor performance based on the widely used outer sample R square or PEA, the mean square for stereo adjusted statistics or Clark and West, and forecast in campus test or Harvey. We made LVP and LAV denote H stable ahead of forecast or volatility for the parsimonious mode and the augmented mode, and we can define corresponding mean square prediction error. And R square, auto sample R square is like R square. However, however, it uses the information prior to T. So the increase of auto sample R square can measure the auto sample performance or the or augmented model, and we will adopt those Clark-West statistics to test the outer sample R square is negative or is larger than 0 or less than 0. And Clark-West statistics adjusted for the fact that the augmented model has to estimate extra parameters. So it extra parameter will introduce estimation uncertainty. So the third term adjusted for this uncertainty. And the third metric or outer sample metric is in campus test. We assume we form optimal combination forecast as a convex combination of two models, and we estimate the lambda. If lambda is 0, it seems like augmented model cannot offer extra information. If lambda is not 0, and the augmented model can offer extra information for forecasting. And this is our outer sample forecasting performance. First, for Bitcoin, it seems like the increase of outer sample R square indicates that we cannot monetary policy cannot give extra information for volatility for prediction or Bitcoin volatility. However, CW test, this is because the parameter estimation error makes the increase R square is necessary. But the model is superior when monetary policy uncertainty is included. And the in-campus test indicates that monetary policy uncertainty still can give some information for volatility for Bitcoin volatility forecasting, and for For other cryptocurrency and market volatility, the results, the auto sample result seems quite aware. For most of their statistics, the increase of R square outer sample R square is positive and significant, and we can see that the in sample for 6 months prediction, the in sample indicator it is not significant. For our sample, even at a 6 months horizon, monetary policy uncertainty still can help. We have examined this. Okay.
Can you go the slides back? So it seems like that when age goes up, some cryptocurrencies converge to lambda equal to 1, and some are going to converge to 1 that is equal to 0. And I think that given that Bitcoin and Litecoin are very related, both converge to more to 0.
Yeah.
And so maybe it's also there is something about crypto networks. So most of the people that hold Bitcoin hold Litecoin. So maybe it's something that's related to this, why you have some coins converge to 0 and some coins converge to 1.
Yeah, it may be, but however, well, in the later section, we examine the net effect, the possible explanation, and it seems like later work effect cannot explain the negative relationship between the volatility of cryptocurrency and monetary policy uncertainty. So, your advice is useful. Maybe I will examine it later. Thank you. Have any questions?
Can I also ask, like, how, I imagine these monetary policies to be quite, let's say, continuous throughout the times, that it's not going to be flipped back and forth. Then, like, can you give us some insights about, like, for example, for these Bitcoin, we see, it's the coefficients are negative in let's say h equals to 1, and then, well, for Bitcoin it's like consistently negative, but you have some that is, for example, LTC, that is, when we consider lag it's 1, it's positive coefficient. When it's lag is 2, it's negative coefficients. Is this due to like the changes in monetary policy, or should we expect some other mechanisms to jump in?
I don't know. Change in monetary policy seems not have a significant impact on volatility of cryptocurrency. So these are the in sample analysis indicators that all indicators that high monetary policy uncertainty implies low volatility of cryptocurrency, and the R square the R square is merit is the increase of R square out the increase of out sample R square is a merit is can the relationship can this negative relationship can improve for cost for volatility forecast, and the negative value indicator it can it can increase the volatility forecast, and positive values means it can improve volatility forecast. And for Bitcoin monetary policy, monetary policy uncertainty cannot improve the forecast. But the CW test indicates that this is because of parameter estimation error. It's not because of model. The model is superior when monetary policy uncertainty is included. Okay, thank you. Anyone has questions? Okay, I will move on. Now we have examined the effect of monetary policy uncertainty on volatility of cryptocurrency. And we all know good volatility and bad volatility has different implications for risk management, asset allocation, and asset pricing. So we will examine the effect of monetary policy uncertainty on good volatility and bad volatility. And the good volatility is upside variance, and the bad volatility is downside variance. We will constructed them according to the limited theory of Bohr. And we also take log value of these values to get a beta behaved. And we also adopt univariate predictive regression, and this is the in-sample results for good volatility. We can see that monetary policy still is a negative predictor of good volatility of cryptocurrency. And for bad volatility, we can see that the predicted power is decreasing, is less than good volatility. This is very contrary. This is contrary to traditional assets. For US stock market, monetary policy uncertainty have more effect on bad volatility and less effect on good volatility. But however, in cryptocurrency market, monetary policy uncertainty seems to have more impact on good volatility. And less impact on bad volatility. And we also examine the auto sample analysis. For Bitcoin, in previous we have shown that monetary policy cannot give auto sample, give a good auto sample forecast for Bitcoin volatility. but for good volatility, monetary policy uncertainty can help the good volatility of the sample forecast. And for other cryptocurrencies, the outer sample result is also opinion. And for better volatility, consistent with the in-sample analysis, monetary policy has poor out sample better volatility forecast, and the out sample forecast for other cryptocurrencies also is less significant. And then we will give some possible explanation, and we examine three possible channels. The first is trading activity channel, and the second is the network effect channel, and the third is investor attention channel. Trading activity will increase cryptocurrency volatility, and monetary policy uncertainty may affect trading activity cryptocurrency, and we will first examine whether trading activity of cryptocurrency will give possible explanation. And this is the result. We can see that monetary policy has no effect, has insignificant effect on trading activity of cryptocurrencies. So trading activity channel cannot give the explanation of the effect of monetary policy uncertainty. And then we will examine the network effect, and in fact, user adoption is crucial for cryptocurrency prices. And in several theoretical models, network effect is parallel to cash flow in traditional assets. So we will examine whether the network effect will give a possible explanation, and we will adopt the number of active addresses as a proxy of user adoption. And we will examine the level of network effect and the volatility of volatility of network effect. It is parallel to cash flow channel and the cash flow volatility channel in traditional assets. First, we can see that monetary policy uncertainty only has a significant effect on network effect of Ethereum and the Dogecoin, and Stena. And however, they not have insignificant effect on network effect of Bitcoin and Litecoin and Ripple. By the way, because Monero, the actual address of Monero is not available. So we cannot examine the network effect of Monero. And then we examine the volatility or network effect, and volatility or network effect is proxied by realized volatility or the number of active addresses, and we can see that monetary policies don't have significant impact on volatility or network effect. So and then so the last hope is investor attention. Investor attention channel. Investor attention will proxied by the number of wiki page views. Although many papers have adopted Google Trend Index, however, for the long samples, some value of Google Trend Index is 0. So we instead adopt wiki page views as our proxy or investor attention. We still, however, we still cannot find the evidence of these channels. So basically, the current theory cannot explain the negative effect on monetary policy uncertainty on volatility, on cryptocurrency volatility. So we will give our inclusion. First, is that monetary policy uncertainty has a significant negative effect on cryptocurrency volatility. However, current theories cannot explain this negative relationship. So a theoretical model is needed, and we want to examine the implication of asset allocation. However, we still don't have time. Maybe later we will examine the predictability, for implication of asset allocation. And thank you very much. And anyone have questions?